Hello and welcome to today's lesson on radioactive emissions, which is part of the atomic structure topic in GCSE Combined Science. Now in today's lesson we're going to look at understanding the properties of radioactive emissions. So if we've been successful and learned in today's lesson, we should be able to understand why radiation is emitted by nuclei, understand the different composition types of radioactive emissions, and finally understand the different properties of the different types of radioactive emissions, which falls into the following part of the GCSE Combined Science Physics Specification 6.4.2.1 Radioactive Decay in Nuclear Radiation. Now scientist Henri Becquerel in 1881 realised that the element uranium was emitting energy in the form of particles. Now this broke the law of energy conservation known at the time, as the energy cannot be created or destroyed, so it seemed that like the rock was creating energy in the form of particles from nothing, which is why it appears that uranium glows in the dark. It is emitting energy, making it glow. However, it was not a violation of the energy of conservation. It was solved when it was soon realised that the energy was coming from the unstable nuclei of the uranium radioactively decaying and releasing nuclear radiation that Becquerel had discovered. Okay, so therefore he was a person who discovered radioactivity. So we had to consider the following ideas. What causes nuclear radiation to occur, and why do some nuclei exhibit radioactive behaviour such as uranium-235 and other nuclei such as oxygen-16 do not exhibit radioactive behaviour. Now it's important to note that nuclear radiation is produced when unstable nuclei emit particles or energy, so change to become more stable. Now this process is called a nuclear decay. Now a nucleus can decay via one of three methods, either alpha radiation, beta radiation, or gamma radiation. So nuclear radioactivity is the process of a nucleus becoming more stable. So unstable nuclei want to become more stable, and they do this via nuclear decay. So you start off with an unstable nuclei and they turn into more stable nuclei after radiation is given off by the unstable nuclei. Now there are three types of radiation: alpha, beta, or gamma radiation, which a nucleus can emit to do this. So just to clarify, this process of becoming more stable is called a nuclear decay. Now it's a decay as the energy is releasing either particles or energy to become more stable. Now a nuclear decay is an event which increases the nuclear stability. So it's important to know that it goes from an unstable nucleus to a more stable nucleus. Now this process only involves the nucleus of the atom, so it's important that we don't use the phrase atom when we're considering radioactive decay. Now radiation is the energy or particles given off by the nucleus to shed this excess energy which makes them unstable. Now like we said before, another name for radiation is radioactive emission, and there are three types of radioactive decay an unstable nucleus can undergo depending on the type of unstable nucleus that it is. But this radiation must always originate from the nucleus of the atom. It is nuclear radiation, and the three types of radiation are alpha, beta, and gamma. Now we call these three types of radiation, we call these ionizing radiation, because the particles ionize particles that they encounter. The radiation can knock electrons out of atoms. So as we mentioned before, in all forms of radiation, the nucleus of the atom is emitting something, and this emission is called radiation. So you can have alpha radiation, beta radiation, and gamma radiation. Now we need to be able to look at the properties of the different types of radiation. Now alpha radiation is the release of an alpha particle, and it occurs in very heavy elements such as uranium and radium. Now an alpha particle is made from 2 neutrons and 2 protons, so has an overall charge of +2 and a mass of 4 atomic mass units. So an alpha radiation is a particle consisting of 2 protons and 2 neutrons. So alpha particles have a positive charge, which means that they would deflect to the south pole of a magnet or the negative of an electrical field. Now the alpha particles have a relatively large mass, which makes them highly ionizing, but they can only travel about 5 centimeters in the air. Now because alpha particles have a relatively large mass, this means they are absorbed by materials like paper or anything denser. Now alpha particles are only emitted from a nucleus. So alpha particles are helium nuclei. They are 2 protons protons and 2 neutrons. Now it's important to note that helium is safe whilst alpha particles are dangerous, as the alpha has no electrons, which means it can rip off electrons from other atoms, and they'll also travel a lot faster than normal helium atoms as they've been ejected from the nucleus of an atom. So alpha particles are very ionizing but have a low penetration and are stopped by paper. But this radiation must come from the nucleus of an atom. So here's a summary showing us alpha radiation. Now, the next type of radiation is beta radiation. Now, a beta particle is emitted when a neutron in the nucleus changes into a proton and releases a negative charge in the form of a fast-moving electron. Now, this electron has a charge of -1 and a negligible mass, and when this takes place, it has occurred because a neutron is turned into a proton. So, beta radiation is an electron. So, all beta particles have a negative charge. Now, this means they would deflect towards the north pole of a magnet or the positive of an electrical field. Now, beta particles have a mass smaller than an alpha particle. This means they would deflect more in a magnetic or electrical field than an alpha particle because they have less mass. But because they have a smaller mass, it means that they are now moderately ionizing, and they would travel about 1 meter in air. So this means that they will be absorbed by an aluminium sheet about 5 millimeters thick, or a lead sheet about 2 millimeters thick, or anything denser. Now, beta particles must come from the nucleus. So a beta particle is different from a regular electron, as a regular electron exists in an energy level around the nucleus, and the beta particle originates from the nucleus, because all nuclear radiation must come from the nucleus of an atom. Now, a beta particle, which is a high energy electron, has a moderate ionizing ability and a moderate penetrating power, and it can travel up to and get blocked by aluminium. Now, here's a summary of beta decay. A neutron turns to a proton, and at that time it will emit an electron as a beta particle in this process. Now, the last type of radiation is gamma radiation. So after a nucleus has emitted an alpha or beta particle, it may still have too much energy, so we say it's in an excited state, and we can get rid of this energy by emitting a pulse of very high electromagnetic radiation called a gamma ray, which has no mass or no charge. So gamma radiation is an electromagnetic wave. It is energy. The gamma radiation has no charge, and this therefore means it does not deflect in either direction in a magnetic or electrical field, and it has no mass. It is only energy, so it is not very ionizing, which means it can travel for an unlimited distance in the air, so it can never be completely absorbed by a material. Now, gamma radiation is reduced by thick lead several centimeters thick, or concrete more than 1 meter thick, or anything denser, but this gamma radiation must come from the nucleus. Now, just to indicate something, gamma radiation is fundamentally no different from visible light. They're both type of electromagnetic waves, which is covered more in a later topic, but gamma is more dangerous than light as it has a higher frequency. So gamma radiation has quite a low ionizing ability but a high penetrating power, and can travel through nearly everything but is reduced by lead. But it's important to note it originates from the nucleus of an atom, which we can show in the following animation here. So we can summarize our radioactive properties of alpha, beta and gamma, and you must be able to state the composition of each one, the deflection in a magnetic and electrical field of each one, the penetrating power of each one, and the ionizing ability of each type of radiation. And really, you're also expected to be able to state the uses of each type of radiation and what can be used to block each type of radiation, and you must be able to compare and contrast the different types of radiation. So what have we learned in today's lesson? Some atomic nuclei are unstable. The nucleus gives out radiation as it changes to become more stable. This is a random process called radioactive decay. An activity is the rate at which a source of unstable nuclei decays when it's measured in becquerels. Now, the count rate is the number of decays recorded each second by a detector, such as a Geiger-Müller tube, and the nuclear radiation may be emitted as an alpha particle particle, 2 neutrons and 2 protons, which is the same as a helium nucleus. A beta particle, a high-speed electron ejected from a nucleus as a neutron turns into a proton. A gamma ray, which is electromagnetic radiation from the nucleus, or a neutron. Now, the required knowledge of the properties of alpha, beta and gamma are limited to their penetration through materials, their range in air and their ionizing power, and you should be able to apply your knowledge to the uses of radiation and evaluate the best source of radiation to use in a given situation. So if you've been successful and learnt in today's lesson, you should be able to understand why radiation is emitted by nuclei, understand the different compositions of the types of radioactive emissions, and finally understand the different properties of the different types of radioactive emissions. I hope you've enjoyed today's lesson where we've looked at radioactive emissions in the atomic structure topic of GCSE Combined Science Physics. Thank you very much for listening and have a lovely day.